I'll just give you 1 more minute and then I will go through it. I'm going to do it now. So the first thing you want to do for any question, remember, write down the information that they gave. So they told you that the center is 1 minus 1, and they told you that the given point is 4, 3. Like I said, if you want to do a sketch, no problem, nobody's going to take off marks for that. If you think that's helping you, that would help you to answer the question, you do you. So this is my circle. Center is this red dot. And they already told me in this question that the center is 1 minus 1. That's the coordinates of the center. So 1 minus 1. They also told me about this point here. They told me that the center passes through this point. So this is what it would look like. Let me use blue. That's what that would look like. Ooh, that's supposed to be a straight line, yeah? And we know that this is the radius because it connects the center with a point on the circle. So we know that's the radius for sure. What they want us to find is the equation of the tangent at this point. So what does that look like? Again, my tangent is the yellow line. We know that a tangent is a line that touches the circle only once. So it touches the circle at this one point, only at this point. It does not touch the circle anywhere else, only at one point. That's very important to remember for a tangent. It touches the circle once. And they want us to find the equation of this line, the equation of the tangent. And we know that there are 4 steps to go about doing that. The first thing we want to do is to find what the center is. But in this case, it's given. They told us that the center is 1 minus 1. So that's step 1 finished already. We didn't have to do anything because they gave it to us already. So step 1 finished. Step 2, we want to find the gradient of the radius, which is this blue line here. Why? As we continue, you'll understand why. So gradient. We know that the formula for gradient, looking up here, m, which also means gradient, is equal to y2 minus y1 divided by x2 minus x1. The first thing we want to do is to identify our coordinates. So the x and y values of our coordinates. This is the center in green, 1 minus 1, and they told us that the point was 4, 3. So this purple point here, 4. We need to identify what is x1, y1, what is x2, y2. What you need to remember from a previous class, coordinates, all coordinates are in the form x, comma, y. So I have my x value here, and then I will have my y value here. We need to identify what's x1, y1, x2, and y2. We did this in a previous class. If you need to, check in the classroom. Right. So you need to remember that they're interchangeable. I could, I could put x1, y1 here. So this coordinate represents x1 and y1, or I could put x1, y2, doesn't matter. I just want these coordinates to be x1, y1, and this to be x2 and my y2. And all I have to do now, using these values, I need to substitute it into my equation to get the gradient of the radius. X2 is 3 minus y1 is 3, y2 is 3, minus y1, which is -1. So that's 3 minus -1. Remember to put your brackets because this would turn into a plus after. X2 minus x1. X2 is 4 minus x1, which is 1. We know that a minus and a minus gives us a plus. So this becomes 3 plus 1 over 4 minus 1 is 3. So we put the 3 there. 3 plus 1 is 4, and then you put it over 3. So that means that the gradient of the radius would be equal to 4 and 3. That step finished. 4 and 3. Okay, let's continue. Stop me if you need to stop me, if you don't understand something. Even if it's the most basic things, ask me. Okay, we'll keep that diagram. All my visuals. The third step, this says to find the gradient of the tangent. Now, this is why we had to find the gradient of the radius first. We know from the previous class that the tangent, which is this yellow line, and the radius, which is the blue line, they are perpendicular to each other. And when we were learning about straight lines, we learned that perpendicular lines, the product of their gradients, so let's say M1 is the gradient of the radius, multiplied by M2, which is the gradient of the tangent, would be equal to -1. This is the same for all perpendicular lines. If a line is perpendicular, if lines are perpendicular to each other, their product would be equal to -1. Remember to stop me if I lost you. M1 in this case is the gradient of the radius. So I would replace that with 4 and 3. M2, this is the gradient of the tangent, and this is what we're trying to find. So I'll put back M2 here. And we know that whatever this value is, M2, which is the gradient of the tangent, the product of M2 and 4 and 3 would be equal to -1. Why? Because these lines are perpendicular. That means they meet at right angles. If I transpose and all that, I will get M2 would be equal to -3 and 4. If you don't understand how I got that, let me know. So we know that's the gradient of the tangent. So that's the finish. Last step. Somebody wants to ask me something?
No, miss. I was thinking that I understand this.
We know to find the equation of any line, y is equal to mx plus c, or we use the other method, which is to use this, y minus y1 is equal to m, x minus x1. People who already did this with me, sorry, class is moving kind of slow, but I need to make sure that everybody's on board. Say we want to use, let me use the first method since we used the second method last time. When trying to find the equation, we need to know the gradient of the line, and we also need a given point. For the tangent, we know that the gradient is minus 3/4, and we have a point that lies in the tangent ray. This purple point here, which is for 3. And we could just substitute those values to get our equation. So using this first method here, y, in this case, my y value is 3, is equal to m, which is the gradient of the tangent, is minus 3 and 4, x, the x value of my coordinates is 4, plus c. For this particular method, what we need to find is the c. So 3 is equal to, these 4s would cancel, these 4s would cancel, so I'll get minus 3 plus c. But we need to get c by itself. We're trying to find for c in this particular method. So what we need to do, add 3 on both sides. And we know that 3 plus 3 is 6. So 6 is my value of c. Did this in a previous class, but if you have any questions, let me know. And that's why the equation of our line for this question is y is equal to m, which is the gradient of the tangent, minus 3 and 4, x, and now we know that c is 6. So we put plus 6. And that is our answer for this question when they ask us for the equation of the tangent. Everybody good with that?
Yes, miss.
Let's just do one question with normal, and then I'll show you. Do this question for me. If you finish already, you could send me an answer, like what you got for the equation of the normal. I'll just give you 2 more minutes to do this. Okay, let's start. For the new people, this right here. So the first thing you want to do, so they give you this, you write down that. Okay, hold on. I need to check that. Okay. Write down all the information that they gave you. So they gave you this, the equation of the circle, and they also told you that the normal passes through this point, 2, 6. Given by 2, 6. We know the steps to go about finding the equation of the normal. The first 2 steps are the same. You find your center. The next step is the same. So I'll just put M for gradient. So find the gradient of R, which is the radius. So let's do that first. You need to notice that this, the equation that they gave us, is in the standard form. X plus h squared plus y plus k squared is equal to r squared. We did this already. Long time ago. Well, not that long, but a while ago. And we know by just looking at this equation, this form, this standard form, and then looking at the equation that they gave us, we could identify what the value of h is and what the value of k is. For newer people, you might be wondering why we need to do that. Because the center has the coordinates minus h and minus k. So what does that mean? The aim, what we're trying to do now, we need to find what minus h is, and we need to find what minus k is, right? Looking at the standard form, which is this in red, and then looking at the equation that they gave us, we could identify what h is, and we could identify what k is. So h here, the standard form says x plus h, and in this equation we have x minus 1. So by looking at this, and then looking at this, comparing them, we could tell that h would be minus 1. That's just eyeballing it. So h, we know already, is minus 1. We could do the same for k. The standard form says that y plus k. Plus k. Looking at this equation up here, we could tell that k would be minus 4. Just in case you're not seeing it, you have y here, you have the y here, you see plus k here, but you see minus 4 here. And that's why k would be equal to minus 4. But we need the center, which has coordinates minus h and minus k. Right now we have h and we have k. So we need to find out what minus h and minus k is. So if h is equal to minus 1, that means that minus h has to be equal to 1. If you don't understand how we did that, let me know. And if k is equal to minus 4, then minus k would be equal to 4. And that's why we found that minus h is 1. So I put my 1 here. We found that minus k is 4. So we put 4 here. And that's why the center, the coordinates of the center is 1, 4. Everybody good with that?
Yes, miss.
All right, so that's step 1 out of the way. We know what the center is now. It's 1, 4. Remember, if you have any doubts at all, please let me know. So 1, 4. Somebody has a question? Please, any doubts at all, let me know. This is the given. Right. So now we know that the center is 1, 4. 1, 4. Next thing we need to do is to find the gradient of the radius. We know to find the gradient, we use this formula. So m, which also means the gradient, is equal to y2 minus y1 divided by x2 minus x1. To do this, we already know eraser, to find the gradient of the radius. So let me just draw the radius. So say this line is my radius. This point here is the center, and the purple point up here is my given point. So 2, 6. 2, 6. And the center, we know now that the center is 1, 4. In previous classes, we learned that to find the gradient, you have to, when using this formula, you need 2 points on the line. So if this blue line is my radius, and I have 2 points on the line, so this red point here and this purple point here, we could substitute these values into this equation to find out what gradient of the radius is. Again, let me know if I lost you. Right. So I'd identify which one I want as x1 and y1 and which one as x2 and y2. So what that means is I'll identify which one I want as my first coordinate and which one I want as my second coordinate. So this one, if I said x1, y1, that's my first coordinate. My second coordinate, x2, y2. And I just use these values, substitute it into my equation to get the gradient. And in this case, the gradient that we're looking for is the gradient of the radius. So this is equal to y2, which is the y coordinate of my second point. This case is the purple one. Y2 is 6 minus y1 is 4. So I put 4 divided by x2. That's 2 minus x1, which is 1. 6 minus 4 is 2. And 2 minus 1, that's 1. But we know that 2 and 1 is the same as 2. And that's why the gradient for my radius, which is the second step, is 2. If I lost you, let me know. Third step. So this is where it varies, right? What we were finding just now is the equation of the tangent. But what we're doing this time is trying to find the equation of the normal. We did this last class, but I need to go over it again, you know, as a refresher. Right. So the third step is the only one that varies. Instead of finding the gradient of the tangent, like we did just now, we need to find the gradient of the normal. Why? Because in this question, what they want me to find is the equation of the normal. Okay, I'm going to end this and then we need to rejoin because we have little over a minute left. So I'll end it and rejoin.